Malaysia Mimi binti Muhammad Fadli, and I'm presenting my final project titled for Plastic Corrosion Inhibition by Coconut Water in LCD and Basic Solution, and this work was supervised by Dr. Shadatul Hanum Rashid. For the background of this study explores coconut water as a green, sustainable corrosion inhibitor for mild steel using various analytical and electrochemical methods to evaluate its effectiveness. The problem statement is conventional corrosion inhibitors are toxic, non-biodegradable heavy metal that pose environmental and health risks. The significance of this study is this research highlights coconut water as a low-cost and eco-friendly corrosion inhibitor. So the objective of this research is to characterize active compound in coconut water using ATR, FTIR spectroscopy and UV-Vis. And second, to investigate the inhibition properties of coconut water on mild steel in LCD and basic solution using weight loss method, PDP and SAM. The literature supports the use of plant-based inhibitor due to their content of organic functional group that adsorb to metal surface. For the ATR-FTIR, previous work identified the key peaks such as OH, C double bond O, and CO, indicating the presence of alcohol, carboxylic acid, and sugar, which can inhibit corrosion. For the UV-Vis spectroscopy has been used to detect UV-absorbing compounds like phenolic and amino acid in natural extract. These compounds tend to degrade over time, which affects their inhibition ability. The weight loss testing is a traditional method to quantify corrosion rate by comparing metal weight before and after exposure, both with and without inhibitor. Potential dynamic polarization (PDP) provides insight into electrochemical behavior, showing how inhibitors affect corrosion potential and current. And lastly, SEM imaging visually shows how effective an inhibitor is at assessing surface morphology, film formation, and pitting. The methodology is divided into four main stages, which is preparation of coconut water, characterization technique, corrosion measurement, and surface characterization. For the preparation of coconut water, the fresh coconut water was filtered and used in various concentrations as corrosion inhibitor. And the characterization technique HAF2, which is ATR-FTIR, was used to detect functional group present in the water, and UV-Vis was used to observe absorbance related to bioactive compound present and stability over time. The corrosion measurement HAF2, which is weight loss method, was used to measure corrosion rate and inhibition efficiency, and the potential dynamic polarization was conducted to analyze the corrosion current density and corrosion potential. Lastly, for surface characterization is cleaning electron microscopy was performed to observe surface morphology before and after exposure to test solution. In the ATR-FTIR analysis, several key absorption peaks were detected in the coconut water sample. For example, OH stretch at 3420 cm indicates the presence of hydroxy group, which are abundant in alcohol and phenols. These groups are known to form hydrogen bond or acylate with metal surface, which helps to block active corrosion site. The C double bond O and OH band at 1725 cm correspond to carboxylic acid, which can donate lone pair to the metal surface and form a protective layer via chemisorption. The IR spectra I have obtained align well with literature data, reinforcing the idea that coconut water inhibition effect is due to compounds like sugar, acid, and polyphenols that are commonly seen in green inhibitor. The UV spectra reveal the following. The high absorbance between 200 to 300 nanometer is typical of aromatic organic compounds such as phenolic, flavonoid, and amino acid. Fresh coconut water showed the highest absorbance, meaning it had the highest concentration of active UV-absorbing molecule. As the coconut water aged, the absorbance decreased, indicating degradation of those bioactive compounds over time. According to Verza, natural extract show UV absorbance below 300 nanometer associated with phenolic, amino acid, and sugar. The aging or degradation results in a drop in absorbance consistent with the loss of UV active compound. The UV findings by me are consistent with Berza, confirming that freshness is critical for maintaining the concentration of effective compound in coconut water. Coconut water reduces the corrosion rate in both acidic and saline environment. Inhibition efficiency increases a higher concentration of coconut water. The natural compound in coconut water likely to adsorb onto the metal surface, forming a protective barrier against corrosive agent. In hydrochloric acid, the inhibition is more prominent due to the aggressive nature of the acid, making the protection effect more measurable. In NaCl, although corrosion is generally slower, coconut water still offers some protection. Coconut water acts as a natural corrosion inhibitor with better performance at higher concentration and pressure conditions. From the PDP analysis, the polarization curve shows a reduction in current density in increasing coconut water concentration in both HCl and NaCl. Lower current density indicates a decrease in corrosion rate, confirming the protective film formation. The shift in curve likely in both anodic and cathodic branches, such as that coconut water inhibits both reactions, indicating it behaves as a mixed type inhibitor. Coconut water modifies the electrochemical behavior of mast, reducing corrosion activity via adsorption of organic molecules. The SEM image clearly shows the physical effect of corrosion and inhibition. In 0.5 molarity of HCl without inhibitor, the steel surface is heavily pitted, rough and severely diminished. This is due to the aggressive acidic environment which accelerates uniform corrosion. With the concentration of coconut water in HCl, the surface is much smoother with fewer visible pits and cracks. This indicates that a protective film formed, which significantly reduces the attack of a hydrogen ion and chloride ion on the metal. In 0.5 molarity of NaCl without inhibitor, the steel shows localized pitting, characteristic of chloride-induced corrosion, especially in neutral or basic solution. In the presence of coconut water in NaCl, surface damage is reduced but still visible, which means the inhibitor is working but not as effectively as in HCl. The SEM provides visual confirmation that coconut water forms a physical barrier protecting the steel from corrosion. However, it's more effective in acidic environment, possibly due to better protonation and stronger adsorption of the organic molecule under low pH. To conclude, coconut water was proven to be an effective corrosion inhibitor for mild steel in both acidic and basic solution. The active compounds in coconut water were successfully characterized using ATR, FTIR, and UVVs. The corrosion inhibition was clearly demonstrated through weight loss, PDP enzyme method. Recommendation for future study is use different concentration and condition, and use advanced techniques like GCMC or HPLC to identify main active compound in coconut water, and also can extend the emission time to assess stability over time.